So looking at this first problem, what I would notice right off the bat is that there's some distribution to do. And there's more than one way to skin this cat, but just kind of seeing that this is one thing I can do is distribute the 6. So I get 6n plus 30 equals 2. So we're done with the simplifying parts. And so then just getting that idea of going back to think about what do I do undo first, right? So we've got an addition of 30, we've got a multiplication by 6, and we're supposed to undo subtraction addition first. So then I'd be subtracting 30 from both sides. That would leave me with 6n equals negative 28. And then we did the subtraction addition there was. Now we'd be looking for multiplication or division to undo. So we've got a 6 times n, so we're going to divide by 6. And so those both have a 2 in them, so I can reduce that down to negative 14 over 3. And negative 14 over 3, if I was going to turn that into a decimal, would equal to negative like 4.67 or 66 repeating. But I don't want you guys to write your answers as decimals. And then if I wanted to write it as a mixed number, it would be equal to negative 4 2/3. But I do not want you writing your answers as mixed numbers either. So I want you to leave your answers as reduced fractions if necessary. If it had been 15 over 3, we would just say 5.
How did you get that? How did you get that?
How did I get what?
Negative 14 over 3.
From here, Audrey?
What?
Like, how did I come from here to here?
Yeah.
So both of these have 2 in them, right?
Mm-hmm.
So I just reduced both by 2.
Oh, okay. You just kind of found like a common
factor.
Yeah.
Just reducing fractions. Yep. So leave your answers as reduced fractions or integers, but no decimals, no mixed numbers when you're writing your answers. Okay. Yeah, and let me know if I'm moving too fast. This is the 3rd time I've done this, so then to start speeding up. Look at the second one. Definitely right off the bat, I'm noticing the parentheses up top and the 3 outside. Telling me that I probably should start with some distribution, just to make that slide a little simpler. So I'd get 15 minus 9x over negative 4 equals negative 15. And then just thinking about our good friend SADMEP. So we're trying to understand what we should undo next, right? So just kind of glancing at the problem, saying, okay, well, here's our x, right? Our job is to get x by itself. So I've got negative 9 times x, so I've got some multiplication. Here's a 15 that's positive, it's adding to the problem, so I got some addition. Then with this negative 4 down here that's dividing, right? So I've got 3 things that are up here, messing around. What do I undo first? So I might think that we need to undo that subtraction addition first. That 15 needs to go away first. And actually, it's not the first thing we do because there's a little hidden set of parentheses on this problem. Parentheses are just a way we group things. And there's other ways to group things. Like when the same operation is happening to multiple terms, those terms then get grouped. So both of these terms are being divided by negative 4. So there's a little hidden set of parentheses around those 2 terms that we just don't write. They're mathematically, but we just, decided that a long time ago we just weren't going to write them. So they're there though. Okay. So what that means is that because the 15 minus 9x is inside the parentheses, I can't deal with any of that stuff until all the stuff on the outside of the parentheses is gone, i.e. this negative 4 needs to go away first. So the appropriate first step here is to, since it's dividing, is to multiply both sides by negative 4 first. All right, and the reason we're doing that, right, is to get rid of that negative 4, not to sit here and distribute. That's not why we're doing that. The reason we're doing that is to cancel that. So that's its job. It's gone. And so on the left side now we have 15 minus 9x equals 4 times 15 is 60. It's positive since they're both negative. Okay. So now we have that positive 15 to get rid of, or that negative 9 to get rid of. If you're not sure exactly what to do here, remember you can rewrite the problem. It's at negative 9x plus 15. Just reorder it. These two things mean the same thing, right? There's negative 9, there's negative 9, there's positive 15, there's positive 15. So just changing the order. I can't change the order and change the sign. Like I can't have 9x minus 15. That's not okay. But they've kept their signs, they just have rearranged themselves. So that's what more like standard form would be. And sometimes it's easier for us to solve when it's in standard form. So you have that option. You can change the way it looks, but you're not changing the way it's, any of the values. So, okay. So if you want to do that, you can. It's okay. But we still want to do that subtraction addition first. I'm going to get rid of the 15. Make sure you bring negative with the 9. And 60 minus 15 is 45. Then go through and divide by negative 9. So then x would equal negative 5. So that'd be our solution. Normally, pretty normal thing for us to ask you guys to do would be to check your answers. We're not asking you to do that here. Just want to show you how that would work if we were to check your answers to see that they work. So we have 3 times 5 minus 3. And we're saying that x is equal to negative 5, so plugging that in. So our job here is to simplify this problem in order to check it. You do not solve while you're checking. And so we should be following PEMDAS here in order to simplify this. So as we look at that, PEMDAS looking inside the parentheses first. And so inside of the parentheses, there's some multiplication to do. Negative 3 times negative 5. So that would give me positive 15 here. So the 3 is going to hang out. The 5 is going to hang out. 5 plus 15, since it's positive 15, over negative 4 equals negative 15. And of course, 5 plus 15 is 20. 3 times 20 is 60. So the numerator simplifies to 60. 60 over negative 4 is negative 15. And 60 divided by negative 4 is negative 15. So we can see that our answer checks. That, why is this the solution? Right, what's that mean for this to be the solution? It means that when we plug it in, the two sides of the equal sign do, in fact, equal each other. Right, that's what we're looking for is the value of x that makes this statement true. So we can see that it does, in fact, make it true. So the incorrect thing to do while you're checking is to start moving stuff across the equal sign. Say, oh, I'm going to get rid of the negative 4, and then I'm going to get rid of the 3, or whatever. Like to start chucking stuff across. Right? That's not okay. You simplify to see if that's equal. Right? Notice how that left side or that right side never changed. Just stayed negative 15 the whole time. Okay. So if we were asking you to check, this would be the appropriate way to do it. I've seen plenty of students check answers incorrectly, in a way that they can have the wrong answer and then check it and see that and make it look that it's right. So it's just something to be aware of. There is a right way to check our answer. There are wrong ways to check answers. Anything 1, 2 you guys want to talk about? If not, I'll ask for ideas on how to start 3. Good, Sam? How should we start 3? Kenzie's up there waiting. Did you get kicked out or something, Kenzie?
Let me distribute it.
I'll distribute the 2, Brian. All right. So that gives 4 minus 14y minus 5 equals 111. Okay, what's next? Distribution first.
Minus 5.
Yep, combine those like terms. So, here we have a choice, right? How do I want to write the problem? So I know I need to combine those two, but I might as well take the negative 14y and push it to the front since I have a choice, right? And then 4 minus 5 being negative 1, and put that second. So, I prefer to have the variable in the front. Mathematically, the numbers don't care where they are. But if it makes it easier for you to solve it, then write it that way. That's easier for you to solve. So Okay, what's next? Add 1, right on, Aiden? In the chat there. So negative 14y is 112. Okay.
Divide by 14.
Divide by negative 14. So, of course, a positive divided by a negative is a negative. Those are both divisible by 2, so that'd be, what, 56 over 7. And 7 goes into 56 8 times. So that'd be negative 8. Okay, so pretty easy, right? Nothing crazy.
Are we going to work on number 4?
Oh, yeah. So, yeah, number 4, I think it's probably the trickiest problem that we're going to do today. Just a lot of fractions going on there. So, and there's just, I think there are a lot of different ways to attack each of these problems. I think with problems with lots of fractions in them, there's probably maybe a better way to do this than maybe we're gonna do right now, but I don't want to shoot too high just yet. So I want to just kind of stick with the method we're going at. Let's simplify it down and solve it. So what should be our first step here as we look at 4? Just even if you don't know how to do it, what should we do?
Distribute.
Yeah, start off with distribution. So, as we're thinking about that, so just, we're not going to change the left side, so still negative 16 equals. And then, when you're multiplying fractions, as we're trying to take that negative 15/16 and distribute it into here, right? When you're multiplying fractions, they're really pretty easy to multiply. You just take the top times the top. So I'm going to grab the negative with the numerator. So negative 15 times 4 is negative 60. And over, and my q is going to drop down. And then positive 16 times 5 is negative 90. Or sorry, just positive 90. Not 90, 80. Okay. And then so there's the first one. Then I need my plus sign. And then, all right, so I'm going to take the negative 15 times 32, and I'm going to take the 16 times the 3. And of course, 16 times 3 is easier there, so we'll do that first. That's 48. The 10 times 32 is 320. And 5 times 32 is 160. So 320 plus 160 is 480. That's going to actually be a negative 480. So what I'm going to do is I'm going to switch this to a minus sign since it's negative. There's our multiplication, right? Now we need to reduce. This one's not too bad, actually. So 60 and 80 both have a 20 in them, so that'd be negative 3/4 q. And then 48 and 480 both have a 48 in them. That's just equal to 10. Okay, so we were able to, it's a lot simpler to look at than what we had earlier, right? So it's now simplified. Now we can go ahead and start solving. So I realize we haven't actually started solving this yet, right? Those first 2 steps were all about making the problem simpler. So
did you say into 480 and 48?
48.
Goes into both?
Yeah, right. There's a 48 right there, right?
Yep.
48 times 10 is 480. So yeah, 480 divided by 48 is just 10. So what should we do now?
Add 10.
Add 10. Right on, Brian. Audrey. So add 10. So we got negative 6 equals negative 3/4 q.
Then we multiply 4 times 6.
Why are we going to multiply 4 times 6, Brian?
Don't you want to cancel that out or move the 4 out of there or something?
You said cancel that out. What do you mean by that? Cancel what
Don't
out?
you want to move or get the equation?
Yeah. Get the 4 out of the denominator. Yeah. All right. So what's the 4 doing, right? And we think about the bottom of fraction, it's 3 divided by 4, right? And so what's the 4 doing? It's dividing. So just like Brian said, let's multiply by 4. So negative 24. So why did we multiply by 4, right? To cancel it out, not to make a 12 or something like that, right? The whole point was to get rid of it. So that just leaves us with negative 3q. And of course, we just divide by negative 3. Say that again?
So yeah, then just divide by 3.
Okay. Yeah, I heard a weird noise there. So now that I'm done, I'm going to shift my q over to the left side. I just like it to look that way. And then 24 divided by 3 is 8. Since they're both negative, I'm just going to leave it as positive. Of course, I could write 8 equals q. That doesn't matter. The numbers don't care. But I just like saying it this way, so I just always write it that way. So. Anything there you guys want to talk about? A little messy. Yeah, I think it's actually number 6 is probably the hardest one on here, but. Oops. Okay. Let's look at 5. It's a really easy one though, but it's the first one we've seen that has variables on both sides. Oh, Mason's sitting outside. Nice. What you guys want to do on 5? How should we start this one?
Add 6a to 10a.
Okay. Why do you want to do that, Audrey?
Because you want the variables on one side.
Okay. So why not move the 10a's towards the 6a's?
Because it's gonna put your number into negative, and then
Yeah, exactly.
move the smaller one all the time.
Yeah. Yeah. So if you focus on the smaller of the two variables, right, the smaller one with the smaller coefficient. So just like Audrey said, we want to move that. So if I add 6a to 10a, that would give me 16a's, right? Or if I wanted to do the other, I want to get my variables on the same side, so I could take the 10a's and subtract them from both sides. And negative 6 and negative 10 would give me negative 16a. But if you're kind of thinking ahead, like our last step has always been to divide by something, right? And chances are when you go to divide, if you divide by a positive, you're going to make less mistakes than if you divide by a negative. Right? Again, the numbers don't care. The numbers are going to work out. The answer is going to be the same. But where are you going to make less mistakes? So it's really what I want you guys to think about is like, what's the simplest way to do this problem? What's the way to work through this where you're going to make the least amount of mistakes? And so less mistakes here is going to be better. Okay. Again, the numbers don't care. You can do it either way. It's just this tends to be the easiest way for students in all the 15 years that I've been teaching. Less mistakes are made when you divide by positives versus when you divide by negatives. So just a good tip, right? And so focus on the variables, right? Gather the variables first, and then look at the constants later. And so since all the variables went to the left, the constants need to go to the right. So that means that we got to get rid of the 7. So they should be, one should be heading one way and the other one should be heading the other way. It doesn't matter which one's going left, which one's going right. That doesn't matter. If the variables go to the right, then the constant should go to the left, or vice versa. Okay. But again, the idea is, they're canceling the constants on the one side or canceling the variables on one side and just shifting on to the other side. So then we get 28 over here. And you can see why this is an easy problem to do because now we just have one more step. So A equals, so those both have a 4 in them. So we get 7/4. Okay, so yeah, so gather variables on one side, gather constants on the other side when you have both, variables on both sides. Yeah, I think 6 is probably the messiest of the problems we'll do today. The rest are pretty clean in comparison. It's going to be kind of like number 4, but. Just like we've been doing, I'm going to start off with that distribution, right? So I'm going to take 1/3, negative 1/3, and times it times 2, and times it times negative 9. So just kind of think about how that works. I'm going to ignore the sign for right now. I just want to talk about the mechanics of that. 1/3 times 2 and 1/3 times 9. Just like we were talking about before, when you take a fraction times something, it's top times top and bottom times bottom. Well, of course, there's a little 1 down there, right, underneath the 2. So when I look at 1/3 times 2, it's 1 times 2 on the top, and then 3 times 1 on the bottom, which is just 2/3. But really, you shouldn't have to do that. Okay, you shouldn't have to do this. Because if you just say, what's 1/3 times 2, it's just 2/3. Right? 1/3 times 2 is 2/3. 1/3 times 9 is just 9/3. The denominator doesn't change because of this, but we don't need to write it down to know that there's a 1 there. We don't need to write down to know that 1 times 3 is 3. 1 times 9 is all I'm really worried about. 1 times 9 is 9. The 3 doesn't change. And then this one I can happen to reduce. Okay? So just think about how we're multiplying those fractions times a whole number. Fractions times whole numbers are really simple. If I say, what's 1/11th times 15? It's just 15/11ths. It shouldn't be a big deal. Okay? So multiplication of fractions is actually really easy. It's the addition, subtraction stuff that's kind of a pain. So left side's not changing, so I'm not going to pay attention to the sign. So negative 1/3 times 2 would be negative 2/3 W. And then negative 1/3 times negative 9 would be positive, and we said that was equal to 3. Right? I'm just taking that 3 there. Okay, so I did some math off on the side here. And then my answers. There's my 2/3, that's that. And here's my 3, that one over here. And I just bring those answers over. You'll see me do that quite often. I'm like, okay, I need to figure out what this is equal to. I'll go do that work over here. And I'll bring my answer back over here so I can then have like a nice, neat transition down line to line. It's easier to follow. And then now, just like we were just talking about on the last problem, right, we got variables on both sides. So let's get those W's in the same place. And just like Audrey said, we want to take that smaller of them and bring it over. So I'm going to add 2/3 W to this side. And since the variables go to the left, the constants need to go to the right. So I'm going to subtract 21. Subtract 21. That cancels, that cancels. So now I have some work to do again. Oops. I need to figure out what this is equal to. So what's 5/6 plus 2/3? How do we do that? How do we do 5/6 plus 2/3? Right, I didn't find a common denominator. So what would our common denominator be, Aiden? 6, okay. So how many sixths are in 2/3? How many sixths is that equal to? Yeah, so if you see what Aiden's typing there in the chat, 2/3 means 4/6. Okay, so if we multiply that by 2, we get 6. That means we have to multiply that by 2. So we get 4/6. And then 5/6 plus 4/6 is 9/6. So again, the denominator is not changing, just like before when we were doing that up here. Denominator stays the same. We have 9 of them, and that reduces. That's equal to 3/2. So what I'm going to do with that, at 3/2, I just found that's 3/2. So that whole time I was ignoring the W. Okay, so it's 3/2 W's. Okay, so 5/6 plus 2/3 is 3/2. So I just then bring the W down. That's equal to, and then 3 minus 21 is negative 18. So if that's something you need to remind yourself, Okay. You guys good to there? Ooh. Yes, no? That's good. Anybody? Yeah. And then just like Brian was suggesting before, let's get rid of that 2 down near the bottom. So we're going to multiply both sides by 2. Again, the whole point of that is to cancel the 2's, not make it a 6 on the top. And so that would leave us with 3w, and then 18 times 2 is 36. So I got negative 36, and divided by 3. So w would equal negative 12. It's a lot of fraction work there. Anything we talked about so far you guys want to go back over or seem okay? June's good. I'm going to skip 7. It's pretty straightforward. Nothing big going on here. I do want to look at 8. Okay. So, with 8, we got some distribution to do, obviously. I think a pretty common mistake that I've seen with something like 8 is where students would try to take this and distribute it, and that's not okay. Or distribution is a multiplication idea. Like when I say 8 times 1 and m, what's multiplying this is what's sitting right out in front of it, which is actually just a negative 1. So there's actually just a negative 1 out here that's going to distribute. The 16 is not multiplying; it's it's subtracting. So that's not going to happen. It's not going to change anything. Since we're distributing a negative 1, not much is really going to change except for those signs, right? So now I'm going to have negative 7m and negative 3 here. And of course, 8 times 1 is 8. 8 times m is 8m. Okay. So avoiding some common mistakes there. Got some like terms here on the left to combine. Make sure you bring that negative along with the 7. 16 minus 3 is 13. And then 8. I'm going to go ahead and switch it. I want to put that m in the front. Again, that's just kind of a personal habit. You don't need to do that. If you want to leave it the way it was, you can. And just like we've been talking about, right now we're into that solving part. Everything else we did is simplifying. So let's gather our m's. So I've, negative 8 is smaller than negative 7. So add that to both sides to keep the coefficient positive, just like Audrey said. And then since the m's went to the left, numbers need to go to the right. So minus 13, minus 13. This one's real nice because the 8 and the 7 just cancel down to a 1. And then 8 minus 13 on the right side is negative 5. So we're all done. Okay, anything there you guys want to talk about on the front? A couple examples I want to do in the back. What are called special cases, and then looking at proportion. Is this the silence of everything's awesome? You're so good at this, Mr. Baker. Okay. So I'll leave these two special cases. We'll look at one of the proportions problems here. So what we've been seeing is that we've been solving or trying to get the variable by itself, right? That's another way to think about solving. How do we get x by itself, or how do we get a by itself, or how do we get p by itself, whatever the letters. And then we're finding a value, right? And we saw that on number 2 or whatever when I was checking it, like that value we found was the number that made the equation true on both sides, right? That both sides equal each other. So that's what I've been after, right? How do I find that one number that makes this all work, right? Well, it doesn't always happen that way. So we have a couple special cases. Start off pretty innocuously, looking at the 11 here. It's like, okay, let's do some distribution. So 1 plus 3c gives me 5 minus 5c plus 8c. And I got some like terms to combine here on the right side. So 1 plus 3c equals 5. And then negative 5 plus 8 is 3. So 3c. So we're done with our simplifying side, right? Our portion of things. And so then we say, well, let's gather our variables. And so at this point, we go, oh, well, they're the same size, right? So what do? Well, either way, we need to move one of them. Doesn't matter which one we move. You get one of them to one side. So we say, well, I can move it by subtracting. And so when we go to do that, right, 1, that's all that's left, and that cancels, and then that cancels, and then it's equal 5, right? So a couple things I've seen students do to getting to this part, right, is I've seen students say, 3c minus 3c, and they somehow like just kind of see the c's go away, and they leave it as c, like 3c minus 3c is c, which is just straight up wrong. Like 3 minus 3 is not 1. And so there's no way for that to be right. Okay, so that's definitely not good. And then the other way, right, 3c minus 3c being 0c, which is right? 3 minus 3 is 0. But why would we write that? Because 0 times c is just 0, and 5 plus 0 is 0. Or sorry, 5 plus 0 is 5. So why would I write 5 plus 0 if I could just write 5? We've never done that before. When I was trying to get my A's on the same side, right? I didn't write 0A here, right? I didn't write plus 0 over here. That's not something we do. So why would I start doing that now? Okay, so even though it's technically right, we just don't do that because it just makes things messy. Okay, so we end up with this part, thing here. It's 1 equals 5, which of course 1 doesn't. What was that? Okay, so of course 1 does not equal 5, right? That's a false statement. So what that really means is that there's no answers here or no solutions. Okay. So we can see why it's a special case, because something happened that was different, right? Where that's really it. That's the all the variables canceled out. So really, what's the special case here? Yeah, that's why it's a special case.
So, even if it said 3 or 3 minus 3c, even if the numbers canceled out, we wouldn't just be left with a c at all.
So if you had like 3, you said 3 minus 3c like that?
Well, yeah, the problem says that, but like the c just disappears too.
You mean 3c minus 3c?
Yeah.
Okay. Well, remember what this means, Audrey, is that, when we say 3c, right, what's that mean? Right, it means 3 times c.
Yeah.
Right, or I have something that's c, whatever it is, and I have 3 of them. Kind of depends on what your frame reference is, right? So I have 3 of them. Well, if I have 3 apples and I take away 3 apples, right, I could say I have 0 apples, or I could just say I have nothing. right? And so think about what's simpler to say, right? Well, now I have nothing. Right? So if I take away all my apples, I have 0 apples. I don't still have an apple left over. Right?
Okay.
So yeah, this means 0, right? I'm taking away all the C's, I'm taking away everything, so it's just down to 0. So, whereas if you do 3C divided by 3, right, that's equal to C. Right? So there's this difference between the way subtraction and division work, right? Or 3C divided by 3C equals 1.
You want to know what it's called?
What's that called?
It's called the flying moon scene.
The flying moon thing.
Scene.
Scene?
Yeah.
Oh, the flying moon scene. Okay.
Yeah.
All right. What am I doing here? Oops, Lord, what did I do? All right, so in the other special case, again, we see some distribution that we need to do there. So I'll start by there. I get 40 minus 8x equals what? Negative 8x plus 40. And again, we kind of, at that point, okay, we're done simplifying. Let's gather all our x's and we go to bring the 8 x's to one side or the other. It doesn't matter which one you're trying since they're the same. And so then, those cancel. They're gone. And so we're down to 40 equals 40. And there's a true statement, right? Last time we had 1 equals 5, which is not true. Here it says 40 equals 40. So that's a true statement. Well, it's always true. 40 is always equal to 40. And so what we say here is that this has infinite solutions. Okay. That basically what that means, I guess, let me explain that. What this means is that there are no values of C that we could ever find that doesn't exist that would make this true. There's nothing we could ever plug in for C that would make this true. This is saying that no matter what we plugged in for C or X, it would always be true. If I plugged in 1, it would work. If I plugged in 10, it would work. If I plugged in negative 10, it would work. If I plugged in negative 1,000, it would work. Every number would work in here. So there's infinite solutions. And so that's any time that you get a true statement. If it's 40 equals 40, if it's 2 equals 2, if it's negative 7 equals negative 7, if it's 0 equals 0, okay? That's the answer. How you interpret that is that there's infinite solutions. I've seen students get to this point and then say, oh, that means x equals 40. Okay, but notice there's no more x's in the problem. Okay, or I've had students get to this part and say, oh, x is 1 or x is 5. Like, they think that means there's 2 answers to the problem. Yeah, that's not what that means. It's the false statement. The variables are gone. So notice on both of them, both special cases, the variable is completely canceled. Okay. So that's what makes it special, that the variables cancel out and you're left with either this true statement, which we interpret as being infinite solutions, or a false statement, which we interpret as being that there are no solutions. Okay. Anything about the special cases you guys want to talk about? Yes, Kayla. Just make sure you do that front side of that worksheet. Okay. Yep. See you tomorrow. All right. I'm going to look at the last problem with you here, 14. And we'll be done. So when you're solving a proportion, right, it's a fraction that's equal to a fraction. Okay. The key there is that you're going to cross multiply in order to solve this. So one numerator times the other denominator, and vice versa. Okay. Make sure that when you're doing this that you're distributing, so that 10 needs to hit the 2x and the 8. So that would give me 20x minus 80 and equals, and then the same way the 8 needs to hit the 9 and the 5x. So 8 times 5 being 40x, and 8 times 9 being 72. Okay. Cross multiplication, when you do that, you get a new equation. you do not get a new fraction. Okay. So I've seen students do it before where they take that 20x minus 80 and they write it over 40x minus 72 or something like that. Now they have this new fraction, and then there's like no equal sign or anything. Like there's no equation anymore. It's just gone. That's not good. Okay, so rewrite it as a new equation to solve. Okay, what you got there?
It's called the singing.
The shinging. That's not very well built. And of course, just like before, let's gather our x's, then let's subtract 20. And then since we're moving the x's to the right, we'll move the constants to the left, so add 72. So it will give me negative 8. And give me 20 x's. I'm going to divide by 20. And since I'm done, I'm going to shift the x back to the left side, just because that's how I like it. And those are both divisible by 4. So that'd be equal to negative 2/5. Okay. So when you're looking at a proportion, just use cross multiplication. It's kind of like a cross multiplying is just kind of a shortcut we can use when we're doing proportions. So you guys would have done a lot of proportions last year in geometry. So all those similar triangles and stuff like that. Anything you guys want to talk about there on the back?
Nope.
Okay.